From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
We wanted to be a B2B business. We wanted to focus on industry. And we didn't want to focus on any of the consumer or personal aspects of 3D printing, which of course has like very valid businesses of its own, but it was just not our area of interest. We, by definition, had to sell to large corporations and large organizations because these were our only customers. But of course, the issue is, when you're very small, it's very hard to get your foot in the door. It's very hard to beat the right people. It's very hard to have the credibility. It was definitely very hard. And I think any small company would say that it's very hard to sell to a large organization. One of the things that is true about B2B sales is that it takes a very, very long time. So you meeting someone today may not result in you getting a contract in your hands, in years.
That was AnnieWang. Annie is the president of Senvol, a global leader in data for additive manufacturing. At Senvol, Annie has overseen the creation of Senvol ML, which is a data-driven machine learning software for additive manufacturing. Annie's area of focus is on analyzing correlation among material properties, process parameters, and feedstock properties. Annie is actively involved in activities across the AM industry. She is vice chair of the SAE Data Management Committee, serves on the Data Integrity Advisory Group and Commercialization Advisory Group for America Makes, and is a member of the ASTM F42 Committee for Additive Manufacturing Technologies. She joins the show today to talk about her startup journey with Senvol, along with a multitude of cutting-edge projects that Senvol has developed over the history of their company. Annie, welcome to the show. Why don't we get started?
Thank you.
Have you tell the audience a little bit about yourself?
Sure. My name is AnnieWang, and I'm one of the co-presidents of Senvol. And Senvol is a database and software-focused company that serves exclusively the additive manufacturing industry. And we have been operating since, I think it's 2013 now. So it's almost 8 years, I guess. It's been a long time. It's been a great journey.
And so for the audience that may not be familiar with Senvol, can you give an example of some work or types of projects or kind of software that you developed?
Yeah, sure. I think for the average person, the Senvol database is probably something that they might have come across or something that they might have used. We developed the Senvol database very early, in the early days of Senvol. And what happened was that in the early days, we ourselves would get asked questions like, hey, what are all the AM machines that take titanium? Or we ourselves were asking this question and saying things like, okay, of all the machines that do take titanium, what is the largest object I could fit into a machine? And there simply was no place for you to go and really search that. The only way you could do it is by, going out and downloading the spec sheets of all of the machines and materials and looking through the spec sheets one by one to pull out, let's say all the machines that take titanium. And then from there, you would say, okay, well, what's the bounded box size of all of these machines in order to answer that question? And so the very first product that we actually developed was called the Senvol database, and it's basically a searchable database of all the machines and materials, and I want to say industrial machines and materials in AM. So someone could go out and just very quickly search, hey, what are all the titanium materials that are out there? What machines use them? What is the size of the machine? And it's not just metals; it's across, all of the different materials that are available in AM and across all of the different machines that are in AM. So that was, I think, our very first product, and it's still heavily used today, literally by thousands of people. And then from there, we developed an API to the Senvol database. So software companies started inquiring us about, downloading the data from the Senvol database. And so we developed an API that they could use to pull that data into the software that they were developing. We also developed a product called the Senvol SOP, which is SOP stands for Standard Operating Procedure, and it's basically a manual for how to generate very pedigreed data sets in AM. And most recently, we are working on machine learning software for AM, and the focus of that is to really understand, the correlations between some of the things that we see in AM, and it's focused a lot on designing your DOE, analyzing data, process parameter optimization, and things like that.
And when you and Zach started the company kind of in 2013, is this kind of the path that you had laid out for yourselves and kind of doing these different products, or where was the real founding idea for coming together to build a company in the 3D printing space?
So Zach and I met each other when we were both doing our MBAs, and we both went into MBA. We didn't know each other going into the MBA, but both of us went into the MBA saying, "Hey, I really want to start my own company. Like, I want to focus on entrepreneurship." And the founding story of Senvol is actually quite silly because Zach and I happened to be in an innovations class together, and the professor asked, "Hey, there's this new manufacturing method called 3D printing," and he literally took out a MakerBot that was about the size of a microwave, and that was the first time I'd ever seen a 3D printer actually. And he asked the class, he said, "Okay, here's this new manufacturing called 3D printing. If you were to start a business, what would you use 3D printing for?" And that was part of the innovation of the innovation class. And everyone in the class had to come up with an idea, and then people voted on ideas. So my idea was to use 3D printing to make spare parts in remote locations like offshore oil rigs and things like that. And Zach's idea was to use 3D printing to make parts for munitions. And Zach and I were the only two people in that class who actually had a really industrially focused idea. Everybody else had ideas of using 3D printing to make, it was more consumer focused or personal focused. So it was making toys, making puzzles, making glasses, making jewelry. And that's kind of how Zach and I met each other. And we worked on this very, very initial idea, which was, how do we use 3D printing to make spare parts for industry, for heavy industry? So that's how we met. And at the time, we really didn't know anything about 3D printing. Like I said, that the day that the MakerBot came out of the box was the day I saw a 3D printer for the first time. And the first thing that we decided was, well, we had to add value to the industry. And what was the value that we were going to add was that Zach and I, because we were in an MBA program, we were very focused on, of course, finance and just, the business aspect of running a business. And so one of the things that we did really well was we did cost modeling really well. And at the time, there was a lot of discussion about, well, what is the true cost of 3D printing something versus manufacturing it using the conventional method? And so we actually started out by developing tools to help companies determine what is the true cost of 3D printing versus the true cost of conventional manufacturing, deciding where was that cutoff point where, yes, it made sense to go for 3D printing, or it did not make sense to go for 3D printing and you should stay within conventional manufacturing. So we started off doing cost modeling and a lot of consulting. And then it kind of went from there. I mean, it was through the cost modeling that we needed to answer these questions like, hey, what are all the machines that take titanium? Or what is the cost of titanium? How many parts can you fit into the build envelope? And that's when we decided that we needed to develop a tool that we ourselves could use, but the industry could also use. So that's how Senvol Database was born. I mean, I would say that, did I ever imagine that one day I would be developing machine learning software for AM? Certainly not in 2013. I think that the path that has led us to where we are, and every product that we developed along the way we developed because we saw that there was some sort of market need. And I think that my biggest advice for anyone who pursues entrepreneurship in any industry, in any endeavor, is that you have to add value to the industry. You have to create a service or a product that people will pay you money for. And that's actually a very simple concept, but it's actually incredibly hard. It is incredibly hard to create a product that adds value that people would pay you for. So throughout the history of Senvol and all the products that we developed along the way, including the products that we're working on now, that we're most focused now, which is the machine learning software, it was all in service of developing products and services that would really help the industry and that our customers were asking for.
Do you still remember the first true customer that you got when you first started the business?
Yes, it was GE.
Okay. Oh, going big right away.
Yeah, I know. Aim high, right?
That's awesome.
Actually, how we got GE as the first customer was also an interesting story because Zach went to a talk by Beth Comstock, who was at the time the chief marketing officer of GE. And after the talk, he kind of just struck up a conversation with her. He was telling her how he has a startup in 3D printing and he's doing the cost modeling. And then she then actually introduced Zach to some of the people inside GE who were actually doing the 3D printing. And then our very first project was helping GE develop cost models comparing the cost of 3D printed parts versus conventionally manufactured parts.
That's great. So just some good old fashioned hustle with getting.
That's right. I mean, I feel like that's the origin story of pretty much every startup.
And you guys have continued that trend to work with a lot of kind of big companies throughout the time, both with the database and machine learning. Kind of, how have you found that process? I mean, from the outside looking in, I could imagine it's kind of intimidating, a small startup going to talk with kind of GE, the Department of Defense, Air Force, whoever you guys may be working with. Like, what's it like navigating some of those relationships as a startup and working with some of the bigger players out there?
I mean, it's incredibly difficult. We're in a B2B business, so we're focused on large companies because it's the large companies who actually use 3D printing in industrial purposes. So like the GEs of the world or the Air Force or the Army, or like the defense manufacturers like Northrop Grumman and things like that. So because we had already decided that very early on, we wanted to be a B2B business. We wanted to focus on industry. And we didn't want to focus on any of the consumer or personal aspects of 3D printing, which of course has like very valid businesses of its own, but it was just not our area of interest. We, by definition, had to sell to large corporations and large organizations because these were our only customers. But of course, the issue is, when you're very small, it's very hard to get your foot in the door. It's very hard to meet the right people. It's very hard to have the credibility. So yeah, I mean, it was definitely very hard. And I think any small company would say that it's very hard to sell to a large organization. One of the things that is true about B2B sales is that it takes a very, very long time. So you meeting someone today may not result in you getting a contract in your hands, in years, not just like a few months. But the benefit of B2B sales or a B2B focused business is that you often deal with fewer but much larger contract amounts. So you often have fewer customers, but each of those customers contribute a lot to your revenue. So you're managing fewer relationships as opposed to like a B2C type business where you're managing many, like in B2C businesses, you could literally be managing thousands or tens of thousands of customers, but each of those amounts are really small. Yeah, so for us, very early on, we leveraged we leveraged the network that we had by doing our MBA at Wharton. Wharton, of course, has a great brand name. We, of course, leveraged the credibility that we got after working with our very first client, which was GE. We spent a lot of our time, networking and really getting to know the people in the industry. So, very early on, we decided, yes, we had to join America Makes. We had to join a lot of these industry organizations like ASTM and SME. We had to go to all of the conferences to meet a lot of people within the industry and also to learn a lot about the industry. So, we've been attending Rapid since the very beginnings of Senvol, and we, and same with AMUG, and later on it was the same with Formnext. So for us, it was a multitude of different factors, but I would say generally speaking, it's always going to be difficult for a small company to try to sell to large players. But I would say that the one thing that you should always keep in mind as a small company is that if you have a product or a service that your customers want, they will not care if you are small or big. If they have a burning problem that you can solve for them, they will find a way to work with you. So in the end, it's all about how much value do you add to that customer, and are you solving a burning problem that they have?
For sure. And I've always found, us being in a similar boat with a small company, we work with big companies in some fashion. There's those kind of annoying bureaucratic hiccups that always come through. Kind of, what business insurance do you have? What
right.
What's your
Absolutely.
payment? What's your PO payment processing system? Are you going to do the work and not get paid for 6 months and having to hound accounting, and they've never done this sort of payment to a company before, and so there's
right.
all of these non-trivial things that tend to pop up as well.
Oh yeah, but I find often those administrative tasks are a double-edged sword. It can be very hard and very long to get into the payment system of a large company, and that literally will take you months. In our cases, we've seen years. But the double edge is that it's hard to get in, but once you get in, you are in the system, and it becomes so much easier to buy from you than to buy from somebody else if they're not in the system. So my advice to any kind of B2B focused entrepreneur or startup is that it's to have the stomach to stay in the industry for a very long time, knowing that the amount of time it takes to network, to close deals is just very, very long.
Right. And so, having been in the industry for a number of years and seeing the many changes that have occurred in terms of different companies, different types of technologies, how do you guys kind of stay up to date, or do you want to continue to focus on specific types of printing modalities, whether it's metal? I know you said industrial, and that every day seems to be encompassing more and different types of processes. Do you ever think about kind of focusing on specific areas with some of your software and tools that you're building?
Actually, no. That's a really great question, but the answer is no. We have never focused on one particular AM process or modality or material. For us, it's the delineation is, are you personal/consumer focused, or are you industrial? And that really cuts across almost, all processes, all materials, almost. And interestingly, for us, the Senvol database is, again, it's industrially focused. It has all the industrial machines and materials in one place. The standard operating procedure is definitely industrially focused, because the only reason why you would want to follow a standard operating procedure is if you're developing pedigree data sets. And the only people who would develop these kinds of pedigree data sets are the large industries. And again, that could be metals and non-metals and a variety of different AM processes. And then the solution that the Senvol machine learning software provides is very industrially focused, because it's all about what is the most efficient way for you to gather empirical data, designing your DOE or design of experiments, understanding the correlations between your parameters and your material properties and performance, optimizing your parameter sets. All of these activities are focused and are done by the industrial players, and all of our products are basically focused on industry, but it doesn't focus on any kind of particular AM process or material or machine or any of that. It's agnostic, but the type of people who would use it are basically the industrial players.
Right. And as you work with some of these big industrial companies, do you see a similar approach when it comes to additive manufacturing and 3D printing, where they're investing heavily, I imagine, in machines, materials, personnel to go through this process of qualification to build their own parts? Or are they looking to kind of build we'd say like a supply chain of people that could support them doing this, where they kind of send out the recipe and we've qualified it on this, copy what we've done and build our parts? What's your kind of take on how does 3D printing move into this kind of next level and stage where it's more in manufacturing and qualified processes? When's the volume come in, or if the business model makes sense for higher parts or more machines or different types of ways to build applications?
I would still say that in today's world, qualification is still really challenging and certification is really challenging. There just aren't that many organizations that actually have an SOP that says this is the exact way in which we will qualify and this is the exact way in which we will certify AM. There aren't that many organizations who really know how to do that. And also, some of the standards organizations like MMPDS and NIAR have been quite late in coming to the forefront and saying, okay, now we will actually write standards on how, as an industry, we should qualify and certify. What I saw in 2013 was, the very early days of Senvol at the time, was a big emphasis on, hey, this is what we've always used, which is, hey, this is the build plan from MMPDS on A basis or B basis allowables. This is the plan that we will use for AM as well. And so what people ended up doing, and actually American Makes funded a lot of projects in doing things like this, is to go out and generate very large empirical data sets at only one parameter point in the entire parameter space that might be available to you. And they would generate a ton of data at that one point, and then they would go and do their statistical analysis, and then they would say, okay, based on that, this is my allowable for this machine and this material. But what ended up happening is that while it was a conventional process that they were very familiar with, it really didn't work for AM because it was a point solution. So the moment you change something about the process, whether you switched your powder suppliers, or you ended up doing a software update on your machine, or maybe you recalibrated your lasers, as soon as something changed, the part and that material and that machine could suddenly become not qualified. And if it's no longer qualified, then what do you do with all of the empirical data and the effort that you put in to qualify it from the beginning? And that was one of the biggest drawbacks of this kind of like point solution, this fixed way, the way of essentially using what MMPDS suggested in the middle of the last century. So like around the time of the Second World War and after the Second World War, what MMPDS and the U.S. military were doing on how to understand qualification of metals, for example, was being applied now to the 21st century, and that really wasn't working. And I think people knew that it wasn't working, but there weren't any really great ideas on what could be a solution. And for us, I mean, we saw this, and for a long time we didn't know what the solution was either, until later on we thought that maybe machine learning could be a really good solution for this. And we basically decided, I mean, bear in mind that while AM is maturing as an industry, the whole, machine learning AI world was also maturing. I mean, machine learning has actually been around. Machine learning is just math. It's been around. Like, that math has been known for decades. And yet it wasn't until computing power got much stronger and faster that kind of machine learning math could be done at scale and at speed to have the machine learning that we see today. So, for example, if you go, I don't know, I mean, there's so many examples of machine learning in your everyday life that you might not even notice, but the one that you might notice the most is the recommendations that you get when you go browse the internet. That, if you bought something on Amazon, Amazon will start recommending you something. If you've seen a video on YouTube, YouTube will start recommending something else. All of that is based on machine learning. So there's literally thousands of examples in how machine learning is actually interfacing with you every day, but you don't really realize it. And our idea was to take machine learning and use machine learning to understand the correlation between the process parameters and the material property and performance. And so our approach was to say, okay, I'm going to step away from the point solution and say, well, instead of a point at which, hey, only this point is the only point that's acceptable for you to be making parts, we're going to look at a process window or maybe a process range or a process area. And within that process range, whether you call it a process range or window or area, this is an area in which you can build parts that meet the requirements that you have set forth. So that is actually a very, very big change in AM that we're proposing. And it doesn't call for sampling data in the same way that MMPDS does. And it also doesn't analyze data in the same way that MMPDS does. But we see a lot of advantages. And one of the biggest advantages is that machine learning is completely agnostic. So you could use it for any machine, material, or process. And also, the best part of machine learning is the word learning, is that it's learning when you give it new data. And so it creates a flexible model that you can then update in the future, and that you can use data sets that you collected before, and you can apply those data sets to learn faster in new experiences. And that particular area is called transfer learning. It's about how do you take experiences that you understand and apply it to an experience that you haven't yet seen. So that's actually really useful, because let's say you are, building, say, stainless steel 316 on one type of machine, and then you want to build stainless steel 316 on a different type of machine, but those two machines are quite similar. Today, in today's world, you would almost throw away all of your old data. You would not be able to use it. But in the world of transfer learning, you would actually be able to use all of your old data and then combine it with some of the new data that you're collecting on this new machine. And eventually what that means is you're able to save time and money, because in your new machine, you'll no longer have to collect as much data as you did in the past, and you create a model that can be updated as things change in the future.
Yeah, that's awesome. And I imagine as you start to work, or you're working with companies and telling people about this, I imagine there's some level of kind of pulling the customer along or the user along in terms of education and thinking, kind of showing them how this could work, given AM is still relatively new within a lot of organizations, not all, but quite a few. Like, they're taking in quite a lot of information, even just in kind of operating the machine, and then throwing on all this additional data and qualification. In some cases, it may be overwhelming for some organizations to manage this, and your tool kind of cuts through that in a way to shortcut it, almost not shortcut it, but like help with kind of that, just the ability to get to ultimately where everyone wants to be, is where I can make this part reliably, and I can rely on the fact that it's going to fit some spec that we've determined.
Mm-hmm. Right. I mean, we for sure encounter a lot of resistance, because anytime you propose something new, you will encounter resistance. I mean, that's kind of inevitable. I think what's been really helpful for us to keep in mind is that different people and different industries and different companies are receptive at different times. There are always going to be some companies and some companies who are very innovative and just are willing to try new things. And there might be certain people within certain companies that are very innovative and willing to try new things and say, I don't know how this is going to go, but I'm willing to try it and I want to try it. We've had people tell us in the past that they came up with the idea of what we're working on now years ago, and they tried to propose it, but no one would listen to them. And that doesn't surprise me in the least. In fact, I think that the biggest hurdle is not technical or even scientific. The biggest hurdle for us is human, is that humans often have the attitude of, if it ain't broke, don't fix it. And also humans, are very like routine and habit-driven creatures. So if you are an engineer and you've done something for your entire career, and you've been working in that industry for say 30 years, it can be very, very hard to change your mind about it. There was actually one particular instance that happened where we were on a phone call with one of the really large defense contractors. They did aerospace and defense. And there were two people on the call. There was an older engineer who was, I think, a fellow. So he was, of course, very senior. And then there was a younger engineer. And in the end, like Zach and I were actually like silent for most of the call because we were listening to the older engineer argue with the younger engineer. And the younger engineer was saying, I don't understand why this can't be done, or like, here are all the technical merits for why this could work or should work. Like, here's all the scientific reasons why it would work or should work. And in the end, the older engineer just said, imagine you have to present this idea in front of this group of people. What would they say to you? And they would just shoot you down. Like, they are going to be resistant to this idea. And there was no scientific reason for why that resistance should exist. But it does. So, and I think most people in the industry would say that a lot of the kind of innovation that needs to happen comes in like very small, I guess, seeds. It's one person in this one organization, or one small team within an organization, or one company within an industry, and they try something new, and then other people look at that and say, oh, that worked. I'm now willing to try it. People are very, very resistant to being the first one to try something new. I mean, there's always going to be people who are very, very innovative and willing to, and are very willing and actually eager to be the first person to try something new. But it definitely takes time, and it takes like a cultural shift that takes more understanding of human behavior than it does understanding of, the scientific merits of something.
Yeah, I think that's an excellent point. And humans are always, in many cases, are averse to risk. And so if you're putting your neck on the line for this new technology or new approach, that's kind of you have the potential to always be tied with that failure, and people overvalue failure in many ways. Absolutely.
I mean, the point of risk is very important because again, Senvol is focused on industry, right? So the kind of parts that people want to make are the parts that are going into planes or missiles or vehicles, and lives are at risk in some cases. And if not lives, then millions of dollars of equipment could be at risk. And so by nature, the type of people that we deal with are very risk averse, and they should be, given the applications that they work with, the industries and companies that they work at. So I think so we are actually compounded by the fact that there's a baseline aversion to risk that is human. And then on top of that, we are serving industries that are all very risk averse.
for sure. And so as we kind of wind down the conversation, we're just at the start of 2021. Kind of what are some of the things that you, Senvol, kind of thinking broadly as the industry progresses and over the year, what are you kind of excited about for the coming months and ahead?
Actually, to be honest, I'm really excited about seeing people in the industry again. It's been a year since I've attended, any of the meetings or the conferences, and I really enjoy those. I mean, I've made friends. I mean, many friends in the industry, and I miss seeing them and being able to talk to them face to face and like hang out with them and ask them, how their company is doing or what projects they're working on or, how their families are doing. I actually really miss that aspect. So it's been rather, unfortunate with COVID situations. But on a more technical side, I think the thing that I'm really excited about are the projects that we're working on that have to do with taking a machine learning approach to developing quote unquote allowable. And so we're actually working on two projects, one with American Makes that's actually focused on polymer materials, and another project with the Army that's focused on metal materials, where we're basically demonstrating how you can use machine learning to gather empirical data sets, to gather and design that empirical data set, to analyze it, and then from there to calculate your quote unquote, what I will call machine learning, but statistically substantiated and empirically substantiated, quote unquote, allowable. So I'm really excited about that. And on our Army project, we actually have an observer on our project who is from MMPDS. So it's great that we can kind of show him like, hey, this is our approach. You can be an observer in our team and tell us what you think and how do you think this would be received at MMPDS. How should we demonstrate it? So that's been really exciting. And then the other piece of, I would say, technical thing that's really exciting that we're working on is on a Navy project that's working on transfer learning, and that's all about how do you use data and experiences from previous projects or from previous data sets to apply to new, unknown, and unseen data sets. And transfer learning really has the potential to allow people to significantly reduce the number of data that they have to capture in the future. Making use of old or existing data sets that you have, and that would help people develop allowables faster and cheaper, qualify parts faster and cheaper, accept changes to their AM process faster and cheaper. So, for example, if they choose to change machines or update software or change their material supplier, being able to accept those changes and kind of roll with the punches, knowing that, hey, there is a path for you to requalify quickly while you use your old data set and you generate, a much smaller data set for your new experience. So those are all really exciting for us.
Thank you for sharing all the cool stuff that you guys are up to and the history. I think it's an amazing story and can't wait to see all the new things you guys are coming out with in the coming months and years ahead. So thank you very much.
Thank you.